Okay, welcome everyone to another ENECON webinar presentation. I will give everyone a few moments here to adjust their volume, your screen, so you can see and hear us properly. I want to thank you for such a great response to this webinar. We have so many people registered all across the US, and a lot of our international markets are represented as well. I know we have people joining us from Europe, from the Middle East, from Asia. So thank you for taking the time to join us for this presentation. My name is Andy Janczak. I'm a vice president with ENECON, and I'm just going to give you a brief introduction for those of you who may not be that familiar with ENECON and who we are, what we do. ENECON is a manufacturer. We're a manufacturer of high performance materials that we use to help our customers all around the world, all across the US, to help them solve some of their toughest repair and maintenance problems. We always say we use our products to help our customers fix things. And it could be issues related to a facility's buildings and structures, chemical protection, roofing issues, flooring, or it could be more along the lines of what we're going to be discussing today, fluid flow related machinery and equipment. And that is what this webinar today will focus on. This will focus on issues related to chiller repair and maintenance. Our presenter today is Matt Goldberg. He is a vice president with ENECON as well. He is in charge of our national sales and operations. He's been with us for more than 25 years, so he has decades of real-world experience dealing with exactly these types of repair and maintenance issues. So I know he has a great presentation in store for everybody. It's going to be very educational, and I know I'm looking forward to it, as are we all. So without any further delay, I'll turn this over to Matt. Matt, take it away.
Hey, thanks, JR, and good morning, everyone, and welcome to our HVAC corrosion webinar series. I'd also like to extend a good afternoon and good evening to all of our people in different parts of the world. This webinar series is going to focus on the types of solutions that ENECON's high-performance polymer systems provide for erosion corrosion problems that facilities face within their HVAC system. HVAC stands for heating, ventilation, and air conditioning, as we all know. We will begin with an overview of a typical HVAC system, and we'll discuss what are the main components of the HVAC system that are subjected to corrosion, discuss the types of corrosion problems that ENECON can solve, discuss the processes that we use to solve these problems, review the ENECON products used to solve these corrosion issues in the HVAC system, and provide real-world examples of completed projects where our products have been used successfully. A typical HVAC system has three primary components. The first primary component is an air handler. An air handler is simply a device that's used to regulate and circulate the air in an HVAC system. Typically, it's a large metal box, as we see in this diagram, that's on the roof. Oftentimes, we see the air handlers placed in different floors throughout the building as well. Most of the problems that we see in air handlers are from the condensation coming off the coils, collecting in the pan and not properly draining out. This causes corrosion over time, and sometimes the corrosion leads to leaks from the unit itself onto the floor in the building where it's not wanted. These types of issues are very easily resolved and will be a focus in a future segment in our HVAC corrosion webinar series. Next in line is the chiller in the system. It's typically comprised of an evaporator and a condenser, and this will be the main focus of this webinar today. The last in the line of the three primary components is the cooling tower. The cooling tower is a heat rejection device that takes the warm water and rejects it out into the atmosphere, and that it completes the HVAC system in a building. Cooling towers specifically have a lot of different types of corrosion issues. You have the water coming into the cooling tower from the top, which we call the hot decks. The water then matriculates down through the cooling tower into the lower collection sump, which creates another set of series of corrosion issues. Also, the cooling tower piping not only is subjected to the mist from the cooling towers, which can cause corrosion over years, but almost from evaporation and environmental corrosion as well. This webinar will focus on heat exchanger and chiller corrosion related issues. Most of the time we work on condensers because they're part of an open loop system with the cooling tower. And this slide depicts the operation of a standard two-pass condenser, which is the most common type of condenser that we see in the field. There's typically a marine water box on one side of the unit, a disc return head on the other, and two tube sheets on each end of the shell. Water comes into the unit through the marine water box inlet side of the water box, passes through the tubes, is turned around by the disc return head, and passes through the tubes a second time out of the marine water box. The water passing through the unit 2 times gives the term two-pass condenser its name. The condenser of a chiller is usually where most of the corrosion issues present themselves. Being part of the open air system with the cooling tower, the unit collects a lot of dirt, mineral scale, debris, and a large amount of oxygen, which promotes the corrosion that we typically see when we come on sites for inspections. A large amount of mineral scale buildup on the tube sheet, corrosion underneath the mineral scale starting to form. Another type of corrosion that we often run into is galvanic corrosion, which is corrosion between the dissimilar metals of the copper tubes and the carbon steel tube sheet. As you can see in this photo, the corrosion is starting to form all over the tube sheet, but really paying special attention in between the tubes where bimetallic corrosion is the most severe. Occasionally, the evaporator bundle is also treated, but they are usually on a closed loop system and much less prone to corrosion. ENECON started solving heat exchanger corrosion issues over 30 years ago for the United States Navy. This newsletter tells the story how the USS Austin was limping in the Mediterranean Sea on one engine due to leaks in one of their main steam condensers. ENECON was contacted, and over a Thanksgiving Day weekend, our products and tech support was flown out to Gibraltar to solve the problem for the Navy. We actually solved the problem a day earlier than had been expected and got the ship back on its way in the Mediterranean. Since that day, the US Navy has been specifying and using ENECON's products and services on literally thousands of heat exchangers. Oftentimes, the ENECON products supplied last well over 10 years in the toughest environments. This project shows that the ceramaloy was originally applied in 1997, and after inspections in 2008, the product was deemed in pristine condition in most instances, and simple touch-up in the field was completed. ENECON's products also have a long track record in the nuclear power industry. ENECON's ceramaloy has passed stringent DBA testing. DBA stands for Design Basics Accident Testing, and these tests are used to determine whether a coating system, or quite frankly, any part of the unit, can be applied and remain on the components in primary containment. These are then called safety-related applications for that reason. In the event of a LOCA, which is a loss of coolant accident, the products cannot prevent the safe shutdown of the plant. Therefore, the products are tested that they cannot peel off, flake, or delaminate while the plant is being shut down safely. Our systems have passed this test, and ENECON has been providing nuclear stations with critical protection for safety-related heat exchangers for well over 30 years. This application is at a Mid-Atlantic nuclear station on their containment fan coil units. This series of heat exchangers is used to cool the primary containment and the equipment inside. Originally applied and in service for 14 years before the station deemed that this heat exchanger had reached its maximum life for the coating, and they reinstalled it. The ceramaloy lasted well over 14 years in brackish water environment. Ceramaloy's 4,000 PSI tensile shear adhesion to prepared steel surfaces helps give our customers the confidence that we can provide them long-term solutions. Since rust can exert a force of 2,000 psi on untreated metal surfaces, our 4,000 psi adhesion in these areas basically eliminates any chance of underfilm corrosion and catastrophic system failure if the ceramic alloy is ever damaged during operation. This allows for very easy in-field touch-ups when routine maintenance is undertaken during plant shutdowns. ENECON's high build process starts by mobilizing to the job site, setting up containment, and installing blast plugs into the end of each tube. The next part of the process is to abrasive blast the tube sheets, water boxes, and end covers to a white metal or near white metal and a 3 mil anchor profile. We pay special attention to the areas between the tubes, making sure we get the roughness that we need to apply our products. It's the area between the tubes that is the most critical part in preventing any type of galvanic or bimetallic corrosion in the future. The next part of the process is to remove the blast plugs, install protective coating plugs, and begin the actual application of the first coat of the Ceramaloy CL Plus AC Blue to the entire tube sheet. You'll notice in this video segment that the CL Plus AC Blue was first applied by an applicator, and then using a stiff bristle brush or a cut down brush, it's firmly pressed onto the substrate, paying special attention to the areas in between the tubes to make sure we get the proper bond in those areas. The next part of the process is to apply the CP plus AC to the tube sheet surfaces. In this video, you'll see that the CP plus AC is pressed firmly in a vertical fashion, pressing down in between the tubes, getting intimate contact between the tube sheet and the tubes and the CP plus AC, pressing firmly, going vertically, then horizontally, making sure we get all the possible air out of the system as we're pressing down. What we're trying to do is maximize the amount of product we use and make sure we don't overbuild on top of the plugs too often or too much. We will allow the product to cure overnight. And this is what we really look for when we're finished with the CP plus AC, almost a honeycomb effect where you can still see the pattern of the plugs through the CP plus AC. Allowing the product to cure overnight, we typically come in the following morning and start the process of removing the excess Ceramaloy CP plus AC from on top of the tube areas, exposing the coating plugs. Once all of the coating plugs have been exposed, we will then remove them. And as you can see from that short video segment, having a little less material on top of the plugs goes a long way in performing the process and getting it done in a timely manner. Once all of the plugs are removed, this is the type of finish that we're looking for. Smooth, monolithic finish, and no gaps between the CP plus AC and the copper tubes. This would be the final thing we do for the chillers. We would apply one final coat of Ceramaloy CL plus AC to the tube sheets, and we apply 3 coats of the Ceramaloy CL plus AC to the dish return heads and water boxes. In 2004, ENECON began a relationship with our first OEM customer, which was York Johnson Controls. This project depicts a project that we did for the Dubai airport. This was actually 55 2,000-ton units that were shipped overseas after the materials were applied at a factory within the United States. Since 2004, we have averaged over 48 high build installations per year for our OEM customers at their factories located in Mexico and in the United States. The units we have protected operate in prestigious airports, universities, pharmaceutical plants, and hospitals in countries all over the world. We have had 0 at-fault warranty issues since 2004. And currently we work with not only Johnson Controls, but also Carrier and Daikin Applied. And we can safely say we are the go-to company for OEM chiller corrosion protection. While full tube sheet and water box high build applications comprise the vast majority of the heat exchanger applications we undertake, some of our customers just need to get their existing equipment back in service. In many of these instances, leaks caused by erosion corrosion of the flange areas underneath the gasket surfaces of the tube sheets and water box get so badly corroded that it prevents the equipment from being buttoned up and put back in service. Over time, water has undercut the flange gaskets, eroded and corroded the metal, eventually preventing the units from keeping a seal when put back together. This type of repair is typically completed in one day and put back in service the following day. The first thing we do to complete this application is complete surface prep on the areas, creating a clean, dry, rough surface to both the tube sheet and end covers that are going to be rebuilt. After the surface prep is complete, ENECON's Duralloy material is applied to the surfaces, typically overbuilding the damaged flange areas in order to rebuild the flanges back to specification. Once the Duralloy has cured, we sand the Duralloy back down, making sure that it's flush all the way around the flanges on the tube sheets and end covers. And the next day, it's put back in service. Duralloy is the material of choice in this application because it has a very quick cure as compared to the ceramaloid paste. Duralloy is ENECON's quick curing machinable metal repair material that exhibits outstanding compressive strength and adhesion and is the perfect product for rebuilding flange areas and other types of metal surfaces as well. Sealing surface repair is a lot of times the name of the game in getting our customers' equipment back up and running. Quite frankly, it's all about the seals, and sometimes it takes multiple steps to complete it. In this application, we originally completed the repair on the flange surfaces, but once we tried to get it all level, we actually had to go back over with a sander, get it flush again, and apply a final coat of the ceramaloid seal plus AC blue. We typically can do this in one day, again, and this was all done in one day and put back in service the next day. Leaking chillers and heat exchangers causes other problems for our customers. You can see from this heat exchanger, the seal's not being kept, leaking from the heat exchanger onto the floor below. Obviously a problem for our customers, and we will discuss this in an upcoming webinar, but just wanted to show that in this application where leaks from an air handler unit were very easily sealed and piping contained to prevent future issues from this leaking air handler in this mechanical room. Some of the problems that we have been resolving more and more are the results of external corrosion on vacuum chillers. Chillers operate at a lower boiling point for the coolant, which increases the efficiency of the unit. What happens is the insulation, as it ages, it starts to allow water or condensation to get under the insulation, causing corrosion issues on the external surfaces. Corrosion under insulation is a big problem for our customers in many instances, and if it's not treated, it can cause air to enter the shell from the corrosion, dilute the coolant, and eventually cause failure of the shell itself. Abrasive blasting or mechanical prep is the first thing that we do to start the process of completing this repair. We'll then rebuild the most severely pitted areas with Duralloy and apply 2 coats of ENECON's ChemClad GP to all surfaces. ENECON's ChemClad GP is the product of choice. It exhibits outstanding adhesion and provides the corrosion protection that we're looking for on this exterior application prior to reinstalling the insulation on top. Another type of vacuum chiller that we've run across more and more is a vacuum chiller. Again, over many years, insulation gets damaged, water penetrates through the insulation to the shell, causing corrosion that must be remedied. We will then do mechanical prep or abrasive surface prep on the exterior of the shell, rebuild the pitted areas with Dorloy, and apply 2 coats of ChemClad GP to finish the application. This webinar has focused on 30+ years of ENECON solving chiller heat exchanger erosion corrosion problems. Some of the problems are very big, some are very small, but the results are always the same, that we provide our customers long-term effective solutions. Regardless of the size of the problem or the location of the problem, we're ready to solve them. And we have proven over the many years that $1 invested with us can save over $10 in conventional repair methods for our customers, translating into millions of dollars of saved over many, many years. That concludes this webinar. If anyone has any questions, we can take them now.
Well, okay, Matt, great work as always. Love the presentation. The photos were great. They were so clear, great videos. I just thought the whole thing was, really understandable and educational. We did have a few questions that have come through. I want to relay those to you and see if you can address them for us. The first one that a couple of people had was, how long does a typical repair like this take? When you're doing it start to finish, a chiller repair, can you give an estimate as to how much downtime a customer can expect?
Well, that's a good question. And oftentimes we really rely on how quickly the customer needs the equipment back in service. And it also depends on the size of the heat exchanger that we're actually coating if we're talking about a high build system. If we have a standard chiller, say 48-inch to 60-inch diameter, we typically have that chiller completed in 3 to 5 days, depending on the needs of the customer, how many guys we're going to put on the job, or if it's something that needs to be multiple crews over a couple of shifts a day. So really, it's up to the customer. We try to work within their parameters, but 3 to 5 days is pretty typical.
Okay. Yeah, another one that we had a couple of times was about quality certification. Does ENECON have any relevant quality certs, and if so, what are they?
Well, actually, ENECON operates under very stringent ISO standards and DoD standards, and we actually keep samples, or retention samples is what we call them, of every batch of product that we make. And we actually keep that product for 7 years in our QA lab. We also follow very stringent QA, QC protocols conducted by NACE and SP2. We want to make sure we have the right millage. We undertake dry film thickness readings after every application to make sure we're falling in line with our specifications. We make sure our quality is always, we show up to a job site and we want to make sure the customer's happy, and we want to make sure the work area is as clean as the customer's expectations are when we leave, not only for the equipment we repair, but the workspace we work in.
Okay, great. Another question that I just thought was something we should address because it seemed kind of critical, it related to safety. The question had to do with protective equipment, ventilation. What's required to work with our materials as it relates to safety, PPE, and that kind of thing?
Well, one of the great things about all of ENECON's products is they're 100% solids with very minimal VOCs. And all of our products can be used within a confined space without any additional PPE other than what the customer calls for a confined space. So most of the applications, as you saw in the video, our guys are wearing the typical PPE, gloves, eyeglasses, safety shoes, things like that. But working with the actual materials, there's actually no additional PPE required.
Okay, well, I think we can all agree we learned a lot. The presentation was great. As you pointed out a couple of times during the presentation, this is the first in a series. Over the course of the next couple of months, we'll be talking about additional aspects of the commercial HVAC loop, if you will, air handlers, cooling towers. So everyone should keep an eye out for invitations to future webinars, because there's a lot of information coming, and I'm sure you'll find it worth your time to be a part of it. So with that, we thank you again for joining us. It was great to have you, and we'll see you soon at our next presentation. Thank you, everybody.